Hello friends, we are now going to discuss this topic in this video, that is stack will be implemented as a linked list. So we have seen in our previous videos that stack is being implemented as an array, and we have also discussed the queue as an array. So we didn't discuss about stack as a linked list and queue as a linked list in our previous videos. So in this video I am just going to show you how stack is being used. Stack is being implemented as a singly linked list, that is in a dynamic memory allocation method. That is, in this example, in this video I am just going to show you how a stack is imagined to be a linked list, and the push operation I am going to describe along with that. And in a later part of this video, that is in the next part of this video, you will get the pop operation, which will be explained in the next video. So first let us concentrate on how the stack is implemented as a linked list by a pictorial representation. I will just draw it on the board and show you how it is being implemented as a linked list in the memory. So let's draw that and just show it to you. Suppose this is a node of a linked list. This is another node of a linked list. You know that stack is a data structure which follows the LIFO discipline, that is last in first out discipline. You are familiar with this. So we'll just follow the same sort of discipline here as well, because we are dealing with stacks only, but not as an array but as a linked list. So in this case, suppose we can write like this, and we can link the nodes in this manner. So this is the first node. Suppose it is a address 505, it is an address 509, this is an address 607 or something like that. So stack has an important parameter. You know that stack has an important parameter called top, because all sorts of operations performed on stack, there is push and pop operation, that is the addition and the deletion operation respectively, are done at the top, done from the topmost position of the stack. That is, whatever is to be added to the stack or pushed into the stack is to be pushed onto the top of the stack, and whatever is to be retrieved or deleted from the stack or popped out of the stack is to be also taken out from the top position. So this top will be the most important parameter of the stack to be reckoned with, and in this example we have taken this entire stack, and it is nothing but a singly linked list, but it is written in an upright position in order to make you understand the concept of the stack, or make you clear about the concept of the stack. That is, this is a stack implemented as a linked list, not as a only linked list. So in this case, suppose there is a value of 10 here, here's a value of 20, here is a value of -5, something like this. So this will contain obviously the value 509, address 509, this will contain the address 607, and this is the null pointer, that is, it is pointing to nothing. So, and the list pointer, whatever is the list pointer we have dealt with in the case of linked list, will not be there, but instead of that we will see that the list pointer can be taken like this. The top can be a pointer, this top can be a pointer which can be thought of as the list pointer, and this is the top pointer which points to the topmost node of the entire sequence, entire linked list implementing the stack. So in this case we have to write structure definitions for a single node of this entire stack, entire linked list, and also a structure for the entire stack data structure. So there will be two structures which we are going to define in this case, unlike the case which we have seen in the stack as an array, where we declared only the stack data structure. But here we will declare the stack data structure, but we will use the stack data structure after, we will just write the definition of stack data structure only after we write the data structure for this individual nodes. So let's start writing the data structure of the individual node. First, type def, suppose I am writing type def struct. Suppose I have given a name node in the other examples where we have discussed about linked list, but here since we are dealing with stack as a linked list, we are going to write, for the purpose of understanding, we are going to write each node as not node but stack elements or stack element or something like that. So I will write like this: stack element, type def struct stack element. What will be there? That is similar to any node which we declare in the case of linked list. That is, it will contain two parts, one data part and one address part. So data part will contain, suppose we have used integer values, you can also use the float values and character values as well in data. So we'll use the integer here. So we have written int data, and we'll write struct stack element star next, and write stack element over here. So this is the structure declaration of a single node, like this one or this one. This is the representative of each individual node of this linked list. And now comes the structure declaration of the stack. So for the stack, we'll write like this: type def struct stack. We'll take only this top. And what is the top? Top is a pointer to this sort of a node, that is a node which is pointing, the node which is a stack element type of node. So top is nothing but a pointer to a stack element. So we will write like this: stack element star top, and nothing else. I will write like this: stack as the name of this data structure. So these are the two structure definitions which we require in order to implement stack as a linked list. Now I will go on to write the push function, where we will see that if any node is to be pushed to the stack, that will obviously be pushed from the top. It will be pushed from the top. For that purpose, suppose we have to take one node and create one node and add it to the stack data structure. And what we will do in that case, we will just write like this. I'm going to write this function over here and will make you understand what I have written over there. So I will write like this: void, suppose I'm writing this, void push. What we'll take, suppose we are going to take one data, and data is nothing but the data which is to be taken in the new node. Suppose this new node which is to be added from the top will also contain a data field and an address field, and this address field is to be linked with this one, and the top is to be updated to this point, to point to this new node which is added from the top, and the data part will occupy this position. So we will take one data part, that is, suppose we are taking an integer data int a, and we are going to take a stack pointer, that is stack star s. We are going to take what sort of pointer? This sort of pointer, that is a pointer to a stack data structure, that is this data structure, that is this one, not this one. Int a stack star s. Now we will start writing the function definition. We will take another node for the creation of this new node. For that, we have to take a pointer to the stack element data structure, that is to this data structure. So we will take like this: stack element star x. So x is a pointer which is a stack element type of pointer, that is x is a pointer which points to a stack element type of data type. So stack element star x. Now we'll dynamically allocate the memory for this x by writing this code. You know this, you're quite familiar with this code because we have seen this code being used in the linked list examples. X is equal to stack element star malloc size of stack element. X is equal to stack element star malloc size of stack element, closing bracket, then another closing bracket, then semicolon. So this is nothing but creation of this memory block or allocating this memory block. So now we will see, we will place this item, this A, that is the data part, into this part. We will place A here. So for that I have to write X data, that is X is a stack element type of pointer. X has two fields, that is the data field and the next field. So X data will contain A and X next. See this, X next will be pointing to what? X next will be pointing to this one, that is S arrow top, because this top is a part of this stack data structure. Stack data structure contains this stack element type of pointer top, and there is a pointer which is taken in this formal argument section. The second formal argument is a stack pointer, and this stack pointer holds this top because top is a part of the stack data structure and not a part of this node data structure, that is stack element data structure. So we will assign the value 505 to be kept over here, so that this gets linked to this one, so that this node is linked to this node, and this will become the top node now. So the original top node, which was previously the top node, will be linked by this way, in this way, to this one, and the top will be updated. So for that we have to do some pointer operations, and that pointer operation is nothing but X next, that is X is this one, X is pointing to this location, suppose it is 777, 777. So X next is equal to S arrow top, S top. X next is equal to S top, that means S top is 505, this is to be assigned in X next. So X next will contain how much value? What is the value? 505. So X next will be 505. So this X next is equal to S arrow top, means X next has a value of 505, that is this X next is holding this address. So that this node is linked to this node. So in this way we link these two nodes. So this node becomes a part of the stack, and the stack contains the node which is containing the value A, that is the address location 777, and that is to be now made the top element of the stack. So what to do that, to implement that? So in order to make it as the top, we will write like this: S arrow top will be now updated by this line of code which I am writing now. S arrow top will be assigned a value which is 777. And what is 777? This is nothing but X. So S arrow top is equal to X, that is X is assigned to S arrow top, so that the top doesn't remain over here. Top points to this location, that is top points to 777. So the top is being updated. So in this way we have done our operation. So this is the push operation which we have written, and these are the structure declarations which are written. So this is the push operation for the primitive operation push for the stack implemented as a linked list. So if you have any doubts or queries related to this part, you can well post your doubts and queries into the comment section so that I can address them. Thanks for watching this video, and please keep watching the next video for the pop operation. Thanks.